Okay, today we're going to be talking about something called compound events. And we've got a little bit of vocabulary. Our first one is a simple event. And really, we've been working with simple events, and that is any event which consists of a single outcome in a sample space. Or when we talk about a tree diagram, it can be represented by just one single branch. Now, that brings me to our next one, which is a tree diagram. And it really is a tree-shaped diagram, and it actually shows the sequential possibilities of the outcomes of a given event. So it shows you every single possibility. So I'm giving you a question here of what's the probability that I get a heads, and then a tails if I flip a coin. So if I flip this coin 3 times, what's the chance I'm going to get a heads, and then a tails? Well, the first thing I'm going to do is go ahead and tell me what would happen if I flipped it the first time. I could either get a heads or a tails. Those are the only possibilities. Well, if I get a heads first, that means the second time I could either get a heads or I could get a tails. If I did it the third time, each of those possibilities have 2 more coming out of them, because I could get a heads and a tails the third time, or a heads and a tails that third time if I got a tails the second time. Now, what happens if I got a tails the very first time? Well, I could either get a heads or I could get a tails. That's the only 2 outcomes for the second time I flip it. The third time I flip it, well, each of those possibilities could either give me a heads or it could give me a tails. No other choice. But now that I'm all done, I see that it gives me a lot of options. In fact, I have 1, 2, 3, 4, 5, 6, 7, 8 different possibilities when I flip a coin 3 times. Now my question said, I want to know what's the possibility I get a heads, and then a tails, which means I need a heads first. I want this path, the heads, to be second, but I want this path, the tails, to be third. Well, how many ways can I get a heads, and then a tails? Only one. 1 out of a possible 8 different outcomes. So my probability would be 1/8. And notice that's only one branch on that tree diagram. So that's called a simple event. A compound event is when I have more than one outcome coming out. So it might be something like, well, what about I want the probability of getting 2 heads when I flip the coin 3 times. Any 2 heads. Doesn't say first and second or first and third. Well, how many of those branches give me heads 2 times, not 3? Well, the one we just did, heads and a heads, that's 1. That gives me 2. This branch gives me 2, a heads, a tails, and then a heads. That branch gives me 2 heads. Okay, and this branch does the tails with the heads and then a heads. There's 2. And that looks like that's about it. So what's the probability that I get 2 heads when I flip the coin 3 times? I got 1, 2, 3 different paths out of those 8. That's a compound event, because that showed me more than one branch on that tree diagram. Now let's look at some examples. Because I could ask something, a compound event, like if I roll 2 die, 2 number cubes, what is the probability that when I roll them and add the 2 numbers on the face that it comes out to be an 8? Well, that can be very hard to do in my head. So I'm telling you for step 1, to make either a tree diagram, which would be a little bit big in my opinion, or a probability model that we've talked about before, like I did here in this table for you, can actually make my life a lot easier. So I put on the top here, whoops, I put on the top, the first die, the first number cube, and I could only have 1, 2, 3, 4, 5, or 6. And then I put down on the side the other number cube, which only is going to have, again, 1, 2, 3, 4, 5, or 6. Now the question asks, what is the sum? Which means if I add those numbers together, what would be my answers? So you can see in this table, I showed what my sums would be. Now the question is, what is the probability that the sum is an 8? Well, look at how many of these are actually 8s. How many actually gave me the sum of 8? 1, 2, 3, 4, 5. 5 of them gave me an 8. Out of, and here's that total number of possibilities we've talked about, how many numbers are up there? How many different possibilities were there when I rolled 2 die and added them together? When I did that, it actually came up to be 36 possibilities. So my answer would be 5 out of 36. When I look at this next example, I'm looking at another different kind of either compound or single event, but looking directly at a tree diagram. So if I had a deli that actually made these grab-and-go sandwiches, and every sandwich either had white or wheat bread, had a type of meat, ham, turkey, or chicken, had a cheese on it, either cheddar or Swiss, and I said, what's the chance when I ran in that store and just grabbed a sandwich out without looking, I'm going to get a turkey sandwich with cheddar cheese on white bread. Again, there's a lot of different sandwiches they can make and a lot of different combinations. So the first thing I suggest is making a tree diagram. This is a perfect example of when it's appropriate. And I'm going to take each item, and I take in the order they gave me. The first thing they gave me was bread, then about meat, and then about the cheese. So you can see down here, I put the bread, then the meat, and then the cheese. And now I'm listing the possibilities under them. Well, under the bread, there was only the wheat and the white. So I write white and I write wheat. Now the meat, there were 3 choices of meat. And that's why you can see right here, I have 3 branches coming out from each of the breads because it could be any of those 3 meats that they put on those sandwiches. And then I list each type of meat that could be on that bread. So I list the ham, the turkey, and the chicken for the white bread. Or for the wheat, the ham, the turkey, and then the chicken for the wheat bread. Now after they put the meat, they're going to put the cheese on there. And again, there were 2 different kinds of cheeses, so each one of those meats can have 2 branches coming out because there were 2 types of cheese. So I then listed the cheddar and the Swiss for each of those possibilities. And when I'm done, look at how many I have. How many combinations of sandwiches do they make? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 combinations. But now let's look at the question. It says, I want to know a specific branch. How many branches have what I want? First of all, I want white bread, so it has to start here. With that white bread, I want the meat to be turkey. Well, the only way to get white bread and turkey is this path so far. And then I want my cheese to be cheddar. Well, there's only 1 branch, and that's it right there. So now that we're going to go ahead and make that ratio and answer the question, what's the probability? There was only 1 branch. That's the number of lines in the diagram of what we want or wanted outcomes. Out of how many total possibilities were there? 12. The chance that I pick up that turkey sandwich with cheddar cheese on white bread is only 1/12. So that's a beginning look of how we can use our probability models and how we can use and what exactly is a compound event and how those nice little, I would say, probability models can help us find those answers. So bring your answers or questions with you to class and we will continue to